All right, Kelly, I'm going to try to explain this right now. Remember that DNA goes to mRNA and eventually winds up as protein once the ribosomes translate it. So proteins are made up of amino acids, right? And we refer to a residue as the individual amino acid, right? So you can think of like a long train. The residue, right, it's got the smoke coming out of the front there. The residue is just one of these carts, you know, on a long train. So I'm sure you're familiar with the kind of alphabet of amino acids, right? These numbers right here, or these letters, would be the sequences of mRNA, okay, the bases, right? And 3 different mRNA bases turn into a certain amino acid. So that's proline, serine. You don't have to memorize names or anything, but just know that those are individual residues there. So if we take all this and apply it to, you've maybe heard of insulin for people that have diabetes. Insulin isn't really working properly. We can see here that this is a protein, right? This would be the sequence of amino acids, right? Glycine, isoleucine, and so on. So if we were referring to the number of a certain residue in here of an amino acid, we would say, all right, this is the first one. Glycine's the first residue, right? Number 1. Isoleucine would be number 2. Valine would be 3, and so on. So what you can do here is say, oh, hey, I know that that's glycine. That's the first residue. Maybe I can look on back to the alphabet here and find out where glycine is. Hey, here it is. So maybe if I change this, one of these sequences, it actually might result into another amino acid that's similar. So let's see, GGG. Maybe if that last G changes, maybe it turns into something else. Or maybe that middle G changes right there, right? That middle G goes to a C, and then we have an alanine. So if we go back to insulin, if that mutation happened where that middle base went to a C, this wouldn't be glycine anymore, this would be alanine. So the first residue would have changed. So you can change the amino acid at this level also at the DNA, right? But usually it happens at the DNA. If you change a base here, then every time it becomes mRNA, that protein's also gonna show that mutation, okay? Because this is the plan, this is the blueprint that we use. So every single mRNA has to look like the DNA. So if you change the DNA, the resulting mRNA is gonna change, and then the resulting protein is gonna change. And you'll see that this is the protein sequence, right? It's going to change. I hope that helps.